Hello, this is Algebra 4.4, Modeling with Formulas. Now, a formula is an algebraic relationship between two or more variables. This means that a formula kind of tells us how these two variables react to one another. So as I affect one, the other variable or other variables will no doubt be affected. And a formula kind of tells us this predictable relationship with them. Now, a formula you already know is the formula for area of a rectangle, which is equal to the length times the width. So if I'm giving the length of the rectangle and the width of a rectangle, I can figure out its area. And if the area is constant and I elongate the length, well, the width itself will be adversely proportional to it, and it will go down. If I'm given this algebraic relationship, though, it's very straightforward for area. But what about width? What's that relationship between the area and the length? In order to figure that out, I have to manipulate the formula to get width all by itself. And to do that, just as before, we're going to do the opposite operation. In this case, it's going to be length times width. The opposite operation of multiplication is division. So I'm going to divide my length here, and whatever I do to one side, I have to do to the other. The lengths cancel out, and I'm left with area over length is equal to width. So that is now the formula for width in relationship to area and length. Now this can also be extended to all other formulas, and we want to just kind of manipulate these to get the variable we want by itself on either side of the equation. So for example, we have the line equation y is equal to mx plus b. M is the slope of the line, b is the y-intercept, and x and y are those variables of this relationship. Now this is all fine and good if I have an x value and I have the slope and I have the y-intercept. What happens if I don't have the x variable but I have a y variable instead? So I want to know what x is equal to in this relationship. In order to figure this out, I actually have to do a reverse order of operations. First thing I'm going to do is I'm going to get rid of any addition or subtractions. I'm going to move them to the other side. So in this case, I'm going to have to subtract my b. So whatever I do to one side, I have to do to the other. So I'm going to have y minus b on this side. The b's will cancel out, and I'm left with y is equal to mx. I'm going to just put this up here, and negative b plus y on that side. Now that I have y minus b on the left-hand side, I still have this m over here on the right-hand side. Since it's being multiplied by x, I have to divide in order to get rid of it. And I'm going to divide by both sides. Because whatever you do to one side, you have to do to the other. In this case, the m's cancel out, and I'm left with x. I write out the formula for x, y minus b over m is equal to x. Now, this is all premised on solving for one particular variable in your formula, not necessarily the one that's already solved for. We manipulate the equation to isolate by doing the reverse operations. And whatever we do to one side, we always have to remember we have to do it to the other side. And this will lead into even things, let's say if we have square roots. So for example, if I have the area of a circle, a is equal to r squared multiplied by pi. I can manipulate this by first, on backwards order of operation, divide by pi, and then divide by pi over here, That's going to leave me with a over pi is equal to r squared. The opposite of a square is a square root. So I'm going to square root both sides. Square root of r squared will give me r. Move this over here. And to solve for r, it's going to be the square root of a over pi is equal to r.